Good afternoon, guys. Today we are going to be talking about conductors and cables. The electrical conductors used in any electrical installation are selected based on, first of all, the amperage, the ampacity. Okay. Then the other parameter that we need to take in consideration is the temperature. And on the temperature, we need to take in consideration the ambient temperature, also the maximum temperature that the shield used to protect the electrical conductor is used. So we have the ambient temperature and the chiller housing used, the kind of material used to chill, to house the electrical conductor. So these are the two parameters that the main parameter that we use, the amperage, the ampacity of the electrical conductor. And keep in mind, the previous video we were talking about that the load, the circuit, the electrical devices that we need to feed up are the one that will be telling me first of all, the protection that I need to use, and second, the electrical conductor that I need to use. But before we move on and use the tables, so let me tell you that the electrical conductors are classified using what is known as American wire gauge, the American wire gauge. And there are two main divisions. Number 6, American wire gauge, the gauge number 6. And when the number is larger than this one, the section, the area of the electrical conductor is smaller. So the electrical conductor is able to transport less amperage. Okay. So for example, gauge number 10 is able to transport a smaller amount of electrical current than gauge number 8. On the opposite, number 4 is able to transport higher amount of electrical current than number 6, number 2, number 3 and number 2, number 3, number 2, number 1, and then we have 1 0, 2 zeros, 3 zeros, 4 zeros. So this number is telling you the size of the electrical conductor, is the area, the transversal area of the electrical conductor. But after 4 0, which is a side, we use a circular mill. So this is, for example, is another way, 250 K, that stands for 1,000, circular mill is telling me that there are 250,000 small wires whose diameter is 0.001 inch, which is this, a thousandth of an inch. So I have 250,000, the 1,000 is the K, of a small piece of wire whose diameter is 0.001 inch. And this is equivalent to have a 0.26 diameter of inch. And this is a quarter of inch, a little bit more than a quarter of inch diameter. So if we check a quarter of inch, so we are going to see that is equivalent to 250,000 or 250 kc mill, which is this diameter. You see, right here, like this. This is an inch, this is kind of a quarter of inch. This is a kind of thick electrical conductor. So 500 kc mil will be equivalent to 0.5. It will be 0.52 inch. That is a diameter, which is like this. This is an inch, so the half of inch. This will be kind of a thick cable, the double. So one more time, the American wire gauge is used to determine the sectional area of the electrical conductor. So smaller the number, smaller the number, using 6 as a division, as a parameter, as a reference, smaller the number, higher the sectional area, higher amount of electrical current that the electrical conductor is able to transport. After 4 zeros, which is a size, we start using circular mil. Circular mil. So a mil is 1,000 of an inch, 0.001 inch. This, for example, 250,000 circular mil, 250 kc mil is equivalent or equal to 250,000 kc mil. Kc mil. This means that I have 250,000 small, very small electrical conductor whose diameter of each of them is 0.001 inch. So all of them together will have a diameter of 0.26 inch, which is like this. Okay, and 400 kc mil is almost half an inch, which is half an inch will be like this. A quarter of inch is like this. Okay, very thick electrical conductor. So that is the first thing. But one more time, in the previous video, we were discussing that the first thing that I do is check the kind of electrical device I need to feed up. And the kind and the amount, checking the documentation, I determine the total amount of amperes that I need. I select my protection and I select the electrical conductor. And the electrical conductor are classified based on the American wire gauge. Okay. And the other parameter that I need to take in consideration is the temperature. So we combine these 3 parameters. On the temperature, we take in consideration the ambient temperature and the maximum temperature that the housing used to protect, to encapsulate, to enhouse the electrical conductor can support the maximum temperature. To select the cable based on the temperature, we use 1 table on the NNC. One table on the NNC. So the table, let me see, 310.15 parenthesis B parenthesis 20, ampacity for no more than 3 single insulated conductor rated up to 2000 volts, supported on a base or ambient temperature of 40 degrees. That is 1 table. The other table, the 310.15B16 allows ampacity for insulated conductor rated up to 2000 volts, no more than 3 current carrying conductor in a raceway, cable, or earth, based on the ambient temperature of 30 degrees Celsius, 80 degrees Fahrenheit. We are going to use this one. Okay, so the table that we use for my explanation is the 310 to explain the temperature concept. 310.15 parenthesis B parenthesis 16, and is located on the NNC 2017, and the page is 70-150. So on this table is nothing is said. I will use the 70 degrees Celsius. So I will use the third column from the left, degrees Celsius, which is equivalent to 167 degrees Fahrenheit. And copper is nothing is said. If the manufacturer is not telling me anything else, I will select copper, which is the third column from the left. Let's say, for example, that I need to feed up electrical devices that are demanding 50 amperes. So the side will be number 8 for 50 amperes. 50 amperes, 50 amperes. The gauge AWG will be number 8 for this environment. Okay, let me explain you this. 20 degrees, this table has been built up using 20 degrees ambient temperature. 30 degrees Celsius ambient temperature. And the material for this column, the material used to encapsulate, to housing the electrical conductor can support maximum 75 degrees Celsius or 167 degrees Fahrenheit. Okay, so we have a margin here of 45 degrees Celsius. Okay, and this is for 3 electrical conductors, 3 electrical conductors, 3 electrical conductor transporting transporting amperage, transporting electrical current. Okay, what happened? And that this include the ground. But what about the neutral? So we have another one. If we include the neutral, and keep in mind the neutral is transporting electrical current, because the electrons, the electrical current leaving the source using any of the hot line is coming back to the source using the neutral. So the neutral is transporting. So we have 4 electrical conductors, 3, but this table is for 3. What happens if I have to include the neutral? The ground doesn't count, because the ground doesn't transport electrical current unless the neutral is broken down. Then I use as a 4 electrical conductor the ground. But if the neutral is okay, I have 4 electrical conductors. But this table is for 3. So what do I do if I need to transport on a pipe, PVC or conduit, 4 electrical conductor? Then I need to adjust the ampacity, because I need to play with the ambient the temperature here, the temperature. So what do? There is another table on the NNC. There is another table. The table is 310.15b parenthesis 3, parenthesis lowercase a. Adjustment factor for more than 3 current carrying conductors. So this is for three electrical conductors. This is for 20 degrees Fahrenheit. Okay, and the 75 is the maximum temperature that the housing, the plastic material, or the material that are using on this electrical conductor is able to support by using 3. But what about if we have 4? We need to use the factor to adjust the ampacity. The table is 310.15 parenthesis B parenthesis 3 lowercase a. And right here, the number of conductors from 4 to 6, I need to multiply this by 8. The factor of multiplication is 0.8, or the 80% of the amperes. So in reality, when I have 4 electrical conductors, the capacity of the electrical conductor to transport electrical current will be reduced by the 80% when I have 4. So in reality, these electrical conductors in this condition, under this condition, will be able to transport instead to 40. Their capacity is reduced to, instead of 50, their capacity is reduced to 40. So I multiply this, the nominal amperage that this electrical conductor is able to transport, times 0.8. So that will be giving me 40. So let me erase here this part, this section, and then put here. I multiply for 4 to 6 electrical conductors. I multiply 50 amperes times 0.8, and this is equal to 40 amperes. Okay, and that is the first adjustment of the ampacity. In reality, this cable, when it's together with 4 electrical conductors, will be able to transport, instead of 50, 40. Okay, first adjustment. The second is the temperature, which is the next table that we need to use. Ambient temperature correction factors, because I told you that this is for 20 degrees Celsius. Okay, but if the ambient temperature, instead of 20, let's say for example is 40, so I need to adjust that temperature and multiply it by 0.88 according to the table 310.15 parenthesis B parenthesis number 2 parenthesis lowercase letter a. So the next table that I need to use, is 310.15 parenthesis B parenthesis 2 lowercase a. And this is if the ambient temperature is different. It's a 20 degrees Fahrenheit, Celsius, around 86 Fahrenheit. Now, what about it will be working at higher ambient temperature? I need to use this table. Let's say that it will be 40, which is very high, Celsius. So the factor will be 0.88. So the factor, let's say for my example, 40 degrees Celsius, ambient. Then the factor will be 0.88. So now I multiply 40 times 88. It will be reduced around 24 amperes. So if I multiply 40 times 0.88, this will be around 33 amperes, rounding, 33 amperes. So in reality, this electrical conductor number 8 by itself is able to transport 50 amperes. But when is combining maximum 3 electrical conductor. But now we need to add a 4 electrical conductor. We have 3 phase plus the neutral. The ground doesn't count. Then there are 4 transporting electrical current. Then we need to adjust it 50, and we use the second table that is telling me, depending on the number of conductors, from 4 to 6, this table is telling me, okay, you will have between 4 and 6 electrical conductors on the same pipe, on the same conduit. Then you need to multiply this amperage times 0.8, reduce it to the 80%, which is 40 amperes. If the ambient temperature is not 20, it's higher than that, then we use this table. And the temperature, let's say in my example, is 40 degrees Celsius. It's extremely high. Well, not extremely, but it's high temperature, ambient temperature. Then this table is telling me, okay, adjust the amperage. Now, the 40 amp, it was reduced because of the number of electrical conductors. Now it's reduced because of the temperature. Okay, and this has an explanation. Okay, each electrical conductor produces a magnetic field, and the magnetic field affects the other electrical conductors. When they are together, plus the metal or the pipe or encapsulated in the same raceway, produce higher temperature. The higher, more electrical conductor, more intense is the magnetic field. The energy produced by each of them, more intense is the heat, and then the heat will affect the motion of the electrons, because some of them will be lost in the middle of the way from the source to the load back to the source. So it's reduced by depending of the number of electrical conductors. If it is 4, between 4 and 6, this table is telling me reduce it by the 80%. Now the ambient temperature, the same consequence, the same effect. The ambient temperature will affect the motion of the electrons. So some electron will be lost in the middle of the way between the source going to the load, coming back, because the ambient temperature, the speed of the electron is accelerated, and then they hit, collide between some of them, some million of them, and the temperature, the ambient temperature affect. In my example, I was telling you that the ambient temperature is not 20 degrees. In my example, it's not 20 degrees Celsius any longer, it's 40. Then I have to use this table to adjust the ambient temperature, to adjust the amperage. So the amperage, that original is 50 amperes, because of the number of conductors is reduced to 40, and because the ambient temperature is higher, it's reduced to 23. Okay, so as I told you, when you select electrical conductor, you take in consideration, first of all, the amperage. And using the amperage, you use the first table, 310.15b, parenthesis 16. That is located on page 70-150. And if nothing is said, we select this table has been calculated for ambient temperature of 20 degrees Celsius, the ambient temperature. And the 70 degrees Celsius is the maximum temperature that the housing, the plastic material, or the material used to protect the electrical conductor can support. Okay, ambient temperature 20 degrees, maximum temperature 75 degrees Celsius. 3 conductor maximum, number A, is able to transport 50 amperes. But if we put 4 or more, between 4 and 6, I need to adjust this original temperature. The temperature will be reduced by, according to this table, by 20%. So I multiply 50 by times 0.8. This table is telling me, okay, you have between 4 and 6 conductor, you multiply the original amperage times 0.8, which is 40. And then I was telling you the ambient temperature. In my example is 40 degrees Celsius. So I use this table, 310.15, parenthesis B, parenthesis A, lowercase letter A, and it's telling me for 40 degrees Celsius, multiply the original temperature, amperage by 0.88. So this 40 amperes, now I reduce to 23, rounding, 23 amperes. And that is the way that we select the appropriate electrical conductor.